Okay, dear subscribers and students aspiring for GATE 2021, another good numerical problem. Let us solve it from engineering mechanics, problem set 2.4, solution 2.6. Don't get panicked by looking at this diagram with so many three cylinders. Let me read out, and it is very simple also. The smooth cylinders, there are three cylinders, three smooth cylinders, 1, 2, 3, rest on horizontal channel. This is a horizontal channel having vertical walls. This wall is vertical, this wall is vertical. The distance between which is A, from this end to this end is A, the value of A is given. Find the pressure exerted on the walls and the floors at the points of contact A, B, D, F. The points of contact are A, B, D, F. We have to find the pressure here. The following numerical data is given. P is 200 Newton, Q 400 Newton, R 300 Newton. Radius of the first cylinder, this one is 120 mm. Radius of the second cylinder, this one is 180 mm. Radius of the third one is 150 mm. And this distance is given as 540 millimeter. So don't look at these things and these things first. Let me explain the diagram which I have redrawn for you. Now let us look at the redrawn diagram, right? Then it will be convenient for you. Look at, let me begin from here. This cylinder having radius R1, from here to here R1 is 120 mm. There is a point of contact here, there is a point of contact here, and the weight of this cylinder is given as P is equal to 200 Newton. So at this point of contact with the floor, it is applying its weight vertically downward. So there will be a reaction force to this side, which is I have written as RB. And here at the point of contact, there will be an action force to this side. So there is a reaction force RA, which I have shown it to this side, RA. And let us come back to the second cylinder, R2. The radius is given as R2 180 mm, this one. So it has 3 points of contact, one here, one here, one here. Here, whatever is the action force to this side, due to that there is a reaction force RD at this point of contact D to this side. Here, the common point of contact between the first cylinder and the second cylinder, here also there will be a action-reaction force. This will be applying a reaction force, let this point is C, to this side. I have shown it as a RC. And this will apply, this cylinder will apply on this cylinder at this point of contact the same reaction force RC to this side, which I have shown it here. Again, this is the common point of contact between this cylinder and this cylinder. So here, the point of contact here to this side is your RE, reaction force, and to this side is your RE, the reaction force. This RE is the reaction force on this cylinder at the point of contact T due to this one. And this RE is the reaction force at the point of contact E on this cylinder due to this one. Here, this RC is the reaction force, normal reaction force at the point of contact to this cylinder by this cylinder. And this RC is the reaction force, normal reaction on this cylinder due to this cylinder, right? Now, then coming back to the third one, the third cylinder, radius R3, means from here to here is R3 150 mm. From here to here also R3, that is 150 mm. Its radius is R2, 180 mm. From here to here is 180 mm. From here to here, not here, from this point to this point is also 180 mm. Again, there is a point of contact here. So there is a reaction force normal to this surface. Let it be RF, which I have shown it like this. Like this. Now, and weight of this one is 300 Newton, weight of this one is 400 Newton, weight of the first cylinder is equal to 200 Newton. Now, if you extend this line, we get a 90-degree angle here. So let this angle is equal to alpha. Now similarly, this line, the line of action of its weight Q, 400 Newton, is perpendicular to this. So I have shown it here. Let this angle is beta. Therefore, this angle is also beta, because this line and this line, they are parallel. This is the transversal. So if this angle is beta, therefore this will be also beta corresponding angle. Similarly, here, this line is parallel to this line. And if this angle is alpha, then this will also be alpha, right? Corresponding angles. Now, let us find out the value of alpha and beta first. Now, if you look at this triangle, the triangle O2GO3, in triangle O2GO3, cos of alpha will be O2G over O2O3. Now how much is O2 from this point to this point? That is interesting, right? Now, this whole length from this end to this end is given as 540 millimeter. From this end to this end is 540 millimeter. 540 minus 180, then minus this much from here to here. That is same thing as radius of the third one, that is 150. 540 from this end to this end is 540 minus 180 and minus this much, which is same thing as 150, is equal to your O2G. So O2G is equal to A minus R2 minus R3. So your cos alpha is equal to GO2 over O2O3. So GO2 I just explained, A minus R2 minus R3. Putting the value, this comes out to be 540 minus 180 minus 150. Now how much is, what is the distance between O2 and O3? Now, from O2 to O3, from O2 to this point is the radius of this one, that is 180. From here to here is the radius of this one, that is 150. So 180 plus 150. So O2, O3 is equal to R2 plus R3, 180 plus 150. Now put these things in a scientific calculator. So your alpha will be, if you put it in a scientific calculator, this comes out to be 0.6363. So alpha is equal to cos inverse that. That comes out to be 50 degree, 28 minute, 43.69 seconds of arc. I will only consider this much. Now, then coming back to how to find beta. Now, if you look at the triangle, O2HO1, right angled here, cos beta will be O1H over O1O2. So your cos beta will be O1H over O1O2. Now how much is O1H? Now again, O1H, this distance will be equal to this distance minus radius of this, that is this much, again minus radius of this, means this whole distance, that is A minus R2 minus R1 is equal to O1H. So So your O1H is equal to A minus R1 minus R2. That comes out to be 240. And how much is O1, O2? That is from the center of this one to the center of this one. Its radius is R1, this radius is R2, so R1 plus R2. So R1 plus R2. Now put the values. This comes out to be 240 over 300. So cos beta is this much. So beta is equal to cos inverse of this. That comes out to be this many degrees. That is 36 degree, 52 minute, 11.63 seconds of arc. We will consider only this much. Once you have found out alpha and beta, then it is very simple. Now let us apply the free body diagram at point O3, that is the center of this cylinder. So there are three forces. From this point to this side is RF. From this point downward its weight 300 Newton, and to this side is the reaction force RE. So let us draw the free body diagram at O3 and resolve the vectors into rectangular components and apply sigma x and sigma y is equal to 0. So that is what I have shown here. So free body diagram at O3. This point is O3. Just I showed you how RF is to this side, R is to this side. R was given as 300 and RE alpha we have calculated as 50 degree 28 minute. 50 degree 28 minutes. So let us first apply sigma y is equal to 0. Now this is along negative y axis. If you drop a perpendicular here, this point to this point will be your RE sin alpha. So RE sin alpha will be balanced by R. So RE sin alpha is equal to R. So R is equal to R over sin alpha. Value of R is given. Alpha you have found out. So by putting this comes out to be 388.9767 Newton. Then apply sigma x is equal to 0. We have been acquainted with how to apply. Now if you drop a perpendicular from here, from this point to this point, if you drop a perpendicular here, from this point to this point will be in the x component of RE, and this much will be how much? Will be RE cos alpha. So RE cos alpha is equal to your RF. So RE cos alpha is RF. So RF is equal to RE. This is your RE which we just found out, cos of alpha. Putting the value, this comes out to be 247.594 Newton. Then let us apply draw the free body diagram at point O2. That is the second of the middle cylinder. Let me show here point O2. From here, its weight is acting downward Q 400 Newton. From this point to this side is your RC. And what else? This RD, reaction force, normal reaction force at the point of contact. You can translate this force parallel to itself up to this point. So from this point towards this side is your RD. So that is what I have drawn here, the free body diagram at O2. This is OQ, this is RC. This is your RE, this is your RD. Now this I have shown as beta, this I have shown as alpha, as it is visible from here. Now I have already explained how this is beta, this angle is alpha. So the vertically opposite of this angle is this one, that is alpha. So now the angle between this RC and this RE is equal to alpha plus beta. Is alpha plus beta. Now let us apply sigma y is equal to 0. Sigma y is equal to 0 means drop a perpendicular here. This much will be your RC sin beta. RC sin beta. Now drop a perpendicular from here. This one will be your RE sine alpha, and Q and RE sine alpha, they are in the same direction, so they will be added. So Q and RE sine alpha, they are being opposed by RC sine beta, to make sigma y is equal to 0. So sine beta is multiplied, goes to the other side, value of Q is put, RE is put, sine alpha is put, beta is put it in a scientific calculator. This comes out to be 1166.754 Newton. Then apply sigma x is equal to 0. Now the x component of RE will be from this point to this point, and how much will be that? Will be RE cos alpha. And the x component of RC will be from here to here, will be your RC cos beta. Both are in the same direction, so that will be opposed by RD to make sigma x is equal to 0. So RD is equal to RC cos beta plus RE cos alpha. We have found out beta alpha, put the values, put the value of RC, put the value of beta, put the value of RE, put the value of alpha, which we have found out. Use it as scientific calculator. This comes out to be this much. Make some corrections in the book, answer given in the book due to printing mistake. And finally, the free body diagram at O1. Free body diagram at O1. And where is O1? That is the center of the first cylinder. Here its weight acting vertically downward, that is 200 Newton. From this point, this RA is pointing to this side, and from this point your RC is pointing to this side. So the free body diagram at O1, P is to this side, and at this point of contact the reaction force is to this side, So there is a reaction force RB and its weight P. They are opposite to each other. And there is RC to this side, and there is RA, the point of contact here. If you translate it and show it here, RA will be to this side. So there are 4 different forces at point O1. So there are 4 different forces at point O1. So that is what I have shown here. 4 different forces. Sigma x is equal to 0 means the component of RC along this axis, that is from this point to this point, will be your RC cos beta, and RA is to this side. They will be equal and opposite to make sigma x is equal to 0. Now put the value of RC, then beta. This comes out to be 933.4426 Newton. Then apply sigma y is equal to 0. This is already along y-axis. This is already along y-axis. Only we have to split this vector RC. Its y component will be from here to here. And how much will be that? Will be your RC sine beta. RC sine beta and P, they are in the same direction. RC sine beta, P, and they are in the same direction. So that will be opposed by RB. So by putting the values, this comes out to be nearly 900 Newton.